Why a broken arm can take forever to heal. About 10% of the 8 million bone fractures in the United States every year fail to heal normally. Smoking, diabetes, use of certain pain medications, low vitamin D levels, and old age are known risk factors, but in a significant subset of cases, unknown factors appear to be involved. Some fractures are slow healing for no obvious reason, and we wondered if there is a genetic basis for those cases, says J. Spence Reed, professor of orthopedics and rehabilitation at Penn State. He and his colleagues selected from their records 33 patients diagnosed with atrophic non-union, the failure of a fracture to knit together on its own within 6 months. As controls, they selected 29 patients whose fractures had healed normally. We found associations between certain gene polymorphisms and delayed fracture healing in a sample of patients, says Reed. Our study was preliminary, but it demonstrated the feasibility of a larger one, which we are now working to set up. Suspected genes using cheek swabs. The researchers obtained DNA from the patients. In each case they checked tiny sites of known DNA sequence variations, single nucleotide polymorphisms, that mark common gene variants. They looked only at the SNPs within 30 genes suspected of involvement in fracture healing. The analysis, published in the Journal of Bone, that were more common in the non-healing group than in the normal healing group, hinting that their respective gene variants may somehow impair or fail to support fracture healing. 2 of these SNPs are within a single gene, which codes for the enzyme nitric oxide synthase 2, NOS2. Prior studies showed that this enzyme is produced early in the fracture healing process, and that deletion of the NOS2 gene delays healing in mice. The other SNP of interest lies within the gene for interleukin-1 beta, a signaling molecule best known as a promoter of inflammation. Interleukin-1 beta is suspected also to be an early orchestrator of new bone growth that knits together a fracture. Larger study needed. The findings point to the possibility that common variants of NOS2 and interleukin-1 beta have reduced function in support of fracture healing, and raise the risk of delayed healing. But Reed cautions that the small patient sample and the small number of genes analyzed means that the results should be considered preliminary until a larger study is done. The researchers are currently planning a study with a larger patient sample and a broader mapping of the genome, to provide a more definitive picture of the gene variants associated with delayed fracture healing. In principle, identifying specific gene variants as risk factors for poor fracture healing would lead not only to the development of patient screening tests, but also to a better understanding of the basic biology of how fractures heal. We could develop mouse models of these genetic polymorphisms, for example, to observe in detail the role they play after a fracture. Reed says. The Orthopedic Trauma Association funded this study. Source: Penn State, republished from Futurity.org under Creative Commons License 3.0. Next, read White House to gun control marchers. Keeping our children safe is a top priority, as thousands of students and parents rallied in Washington to demand stricter gun control laws. The White House sent out a message to applaud those who gathered for exercising their right to free speech. Read more. John Bolton will seek to redefine U.S.-China relations and push back against aggression. News analysis: decades of a conciliatory approach by the United States toward China could be finally coming to an end, as President Donald Trump has tapped John Bolton to be the next national security. Read more. After threatening veto, Trump signs $1.3 trillion spending bill. After briefly threatening to veto the $1.3 trillion government spending bill, President Donald Trump signed the measure on Friday, March 23. While lamenting the measure's many flaws, the president said that it had to. Read more.